So, polarization phenomena has some major application. The main part is during the phenomena of polarization there is a intensity control. We can decrease the intensity, and this is the main application of the phenomena of polarization. So, the first application is phenomenon of polarization by reflection. Brewster phenomenon by reflection is used to cut out or decrease the glare to decrease the glare. So what is meant by glare? So when you are traveling on highway, there are some hoarding, advertising board. So light is reflected from that advertising board. It is a powerful light reflected and it may produce some accident. So to reduce this effect of glare, the front glass of the four-wheeler is made by this polarizing material. So intensity is reduced, also some part is reflected back and this phenomena of polarization is used to avoid the effect of the glare. So this glare it may be produced by reflection. Glare is produced due to reflection of light from surfaces like GI sheet used in the roof of factories. Second, from hoardings, advertising board. Advertising boards on highway. From ice coated surfaces. Ice coated mountain. So during the playing this game on ice skating, etc., that skater always use the spect and it uses the sunglasses. So to avoid this glare, use sunglasses. So sunglasses are used for this purpose. Second, sunglasses are used for another purpose. The sunglasses, they are also called as Polaroids, are used to reduce intensity of light partially or fully, like this. Third, partially means it is reduced to half power. The windows of a computer cabin or hall are coated with polarizing film. कॉम्प्युटर क्लासची जर आपण एखादी बिल्डिंग जर बघितली तर त्याच्या ज्या विंडोज असतात रोड साईडला ओपन, तर त्याला बाहेरून ब्लूइश किंवा ग्रीनिश कलरचे पेपरचं कोटिंग केलेलं असतं. तर तो पेपर जो असतो तो पोलरायझिंग फिल्म असतो. सो मेजर portion of the light is reflected and very small light is entering, and again its intensity is reduced so that the temperature is maintained. कॉम्प्युटर सिस्टीमचं टेम्परेचर जर अबोव 55 गेलं तर त्याचं माल प्रॅक्टिसिंग सुरू होऊन जातं, ते माल फंक्शनिंग सुरू होऊन जातं. त्याच्यात तिथे टेम्परेचर कंट्रोल करावं लागतं. सो कॉम्प्युटर केबिन और कॉम्प्युटर हॉल दे आर हॅव्हिंग द विंडोज कवर्ड विथ दिस टाइप ऑफ पोलरायझिंग फिल्म. Same purpose is served here. In train, the AC cabins and in aeroplane, the windows use of polarizing glasses so that the intensity is reduced. तर ट्रेनमध्ये AC केबिनमधलं टेम्परेचर मेंटेन करायचं असेल तर बाहेरची इंटेन्सिटी लाईटची आपल्याला कंट्रोल करावं लागते, रिड्यूस करावं लागते. सो टू मेंटेन low temperature in AC cabins of railway, train or aeroplane, the windows are having the glasses made by polarizing glasses, or you can say Polaroids, made by Polaroids, like this. The front glasses of four-wheeler vehicle are made by Polaroid. Take the reason to reduce the intensity of incoming light. In photography, we use the camera. So for good quality of photograph, the camera lenses are also using the polarizing film. They are called as a filters. The filters used in camera lens are made from Polaroids, which uses Polaroids to reduce glare. The photographic quality is amazing. So these are some applications of Polaroids and Polarisation. Now, last time we have seen there are 5 methods. There are 5 to 6 methods to produce the plain polarized light. One is a polarizer, second one is a reflection phenomena, Brewster phenomena, third one is the double refraction phenomena, nickel prism, then dichroism, scattering, like this. So we have seen 2 methods, reflection phenomena, Brewster phenomena, polarizer, and the third method that we are going to see is the scattering. So polarization by scattering. By scattering of light. So this is the next article, 7.72, polarization by scattering. So let us see the phenomena of scattering. What is meant by scattering? Scattering of light. So when light is incident on the particles, dust particle, air molecule, etc., it is reflected in different directions. Law of reflection may or may not be obeyed. This is called the phenomenon of scattering. So when the sunlight strikes the air molecule or dust particle present in the atmosphere, it changes its direction and the reflected light travels in the different direction. This phenomenon is called as the scattering of light. When sunlight strikes the air molecule, dust particles, in atmosphere, then the reflected light travels in different direction. This is called scattering. So if this is the dust particle and this is the incident ray, then the reflected ray may be going in this direction, in this direction, in this direction, in this direction. So this is a scattered light shown by blue color, scattered light, and this is a incident light. incident light. This is a molecule. Maybe it has particle like this. So this is called as scattering. So law of reflection, I is equal to R. Laws of reflection may or may not. Laws of reflection may or may not be obeyed in the phenomena of scattering. In the phenomena of scattering. So this is the phenomenon of scattering of light. त्याचे applications काही आपल्याला माहिती पाहिजे. The sky appears blue because of this scattering phenomena like this. So we can observe the planet even during the daytime. This is also due to this. So now how the plane polarized light is produced like this. So in this figure, this is the say scattered light having angle of scattering theta 1. This is the angle of scattering theta 2. This is the angle of scattering theta 3. This is the angle of scattering theta 4 like this. So theta is equal to angle of scattering is equal to angle between direction of incident light and scattered light. Angle between the, so when theta is equal to 90 degree exactly, then the scattered light is plane polarized light. Plane polarized light. But if theta is not equal to 90 degree, less than or more than, then the scattered light is partially polarized light like this. So this is the phenomenon of scattering of light. So the scattered light reaching us from different direction is polarized to different degree of polarization. So degree of polarization is different in different directions of scattered light. Like this. So we can produce the plane polarized light by scattering, but it is a natural phenomenon. We cannot control the angle of scattering. For those rays scattered by angle of scattering 90 degree are only plane polarized light. So this is about the phenomena of polarization. Now, in the remaining part, we are going to see two more phenomena, interference and diffraction of light. So before that, we will see some problem on polarization phenomena like this. So question number 1. Third MCQ. When unpolarized light is passed through a polarizer, its intensity increases, decreases, remains unchanged, depend on the orientation of the polarizer. So intensity decreases to half. So we have seen this result. If this is a polarizer, then this is the incident intensity I0, then the transmitted intensity I1 is equal to I0 by 2 always. So this is unpolarized light. Unpolarized light. Therefore, on passing unpolarized light, through a polarizer, intensity of light decreases. Intensity of light decreases. So this is the correct answer. Therefore, B is correct. B is correct. Question number 17. Unpolarized light of intensity I0 is incident on two Polaroid. The axis of the first Polaroid makes an angle of 50 degree with the vertical, and the axis of the second Polaroid is horizontal. What is the intensity of the light after it has passed through the second Polaroid? The second Polaroid is a dipole intensity which are very high. So the situation is like this. These are the two polarities. This is the vertical line. So the first polarity is kept with its axis like this. Even. So this angle is 50 degree. So incident intensity is I0. The transmitted intensity is I1. Now the second polarity is horizontal. P2. So from vertical, this angle is this angle is 90 degree. Is equal to theta 2. This is equal to theta 1. So the light transmitted through it is I2. I2 is equal to question now. Let I0 is equal to intensity of unpolarized light incident on polarizer P1. Polarizer P1. Therefore, I1 is equal to I0 by 2 is equal to intensity of transmitted intensity of plain polarized. This light will be plain polarized light transmitted through P1. So this is the question 1. Let I2 is equal to intensity of light transmitted through polarizer P2. Therefore, by Malus law, I2 is equal to I1 cos square theta. So this is the question capital A, where theta is equal to angle between polarizing axis of P1 and P2. So this is the vertical line. This is P1. This angle is theta 1. This is second axis P2. This angle is theta 2, and the angle between the two axes is the theta. Therefore, theta is equal to theta 2 minus theta 1 is equal to 90 degree minus 50 degree is equal to 40 degree. This is equation 2. The equation capital A gives I2 is equal to I0 by 2 into cos square 40 degree, and therefore I2 is equal to 1/2 I0 cos square 40 degree. So this is the correct answer, like this. I0 by 2, it is the intensity from the first polarizer, like this. Now we will solve some problem from other books. Only one problem is given in our board book. It is insufficient, and therefore we will see some problem from outside book. So this is the first example I have written on the board. Now I will read it. A ray of light traveling in air strikes a plate of the crown glass at an angle of incidence 57 degree and 18 minutes. The reflected and refracted light are perpendicular to each other. Then what is the refractive index of the crown glass? So this condition is important. When the reflected and refracted ray are perpendicular to each other, then it is a Brewster's phenomena, and then mu is equal to tan of theta p. Theta p is given this. So what is the given quantity? Answer: when a reflected and refracted rays of light are perpendicular to each other, then by Polarisation phenomena. By Polarisation phenomena, I is equal to theta p is equal to polarizing angle second, reflected light is plane polarized light. Reflected light is plane polarized light and a refractive index of the medium mu is equal to tan of theta p. This is Polarisation law. Therefore, I is equal to theta p is equal to 57 degree 18 minute and mu is equal to cosine. This is our problem. So, by Polarisation law, a refractive index of crown glass mu is equal to tan of theta p is equal to tan of 57 degree 18 minute. So, from log table, from the table of natural tangent we can get the value natural tangent 57 degree and 18 minute. So it is 1.5577. So mu is equal to this much. So this is the correct answer. Our refractive index is like this. Actually, this refractive index of the medium mu, it is related with three laws. The Snell's law is the sin of I upon sin of R. It is also related with the mu is equal to tan of theta p, polarization phenomena, Polarisation phenomena, and this is also equal to 1 upon sin of IC, critical angle. IC is a critical angle. So these three equations can be coupled to each other for solving the problem. Like this. So see this relation. Mu is equal to sin of I upon sin of R. This is Snell's law of refraction. Mu is equal to tan of theta p. This is the Polarisation law. And mu is equal to 1 upon sin of IC, where IC is the critical angle for total internal reflection phenomena. So this mu is combinedly used in refraction, in polarization, and in total internal reflection phenomena. So they can be coupled to each other for solving the problem. Next problem. The Polarisation angle for a medium is 53 degree 3 minute. Calculate the critical angle for the same medium. So we are giving Polarisation angle theta p. It is also called as the polarizing angle, and we have to find the critical angle IC. So 53 degree 3 minute means the medium is water. for air water interface. This theta p is 53 degree and 3 minutes. So what is our problem? Theta p is equal to this 53 degree 3 minutes and what to find critical angle IC. So you can solve the problem in 2 steps. Step number 1. First we will find refractive index. You can couple these two equations by Brevister's law. Ri of medium mu is equal to tan of theta p. Therefore, mu is equal to tan 53 degree 3 minutes, and it is equal to, again from log you can get the value from natural tangent table. 53 degree complete and 3 minutes. So 3 minutes means 25 minutes. So 1.3295. So this is equation 1. Now once we know mu, second step, by total internal reflection TIR, mu is equal to refractive index is equal to 1 upon sin of IC. IC is equal to critical angle question mark. We have to find this value. Therefore, sin of IC is equal to 1 upon 1.3295. So it is approximately 1.33. This is 5, so it will become 10, it will become 33. So this is equal to 1 upon 4 by 3. So that is equal to 3 by 4. So sin of IC is equal to 0.75, and therefore IC is equal to sin inverse 0.57500. And now from the table of natural sine you can get the value like this. In the table of natural sine we will see the inverse. So we know the method for finding the inverse. (7500). So the nearest number is 7501. So 48 degree complete 36 minutes, nearly 48 degree and 36 minutes. (48 degree and 36 minutes). So we are combining these two relations. So I will read this next problem. The refractive index of the medium is 1.732. What is the angle of refraction in the medium if unpolarized light is incident from air on it at the polarizing angle of the medium? The angle of incidence I is equal to polarizing angle theta p. तर I is equal to theta p असेल तर ही रिफ्रॅक्टिव्ह इंडेक्स म्हणजे tan of theta p ब्रिव्हेस्टर्स लॉ आपण यूज करू शकतो. सो दिस रिफ्रॅक्टिव्ह इंडेक्स म्यू इज गिवन 1.732. So from this we can find I is equal to theta p, and then we can find angle of refraction R. R is the angle of refraction. So when I is equal to theta p, then by Brewster's law, tan of theta p is equal to mu is equal to 1.732, and therefore theta is equal to tan inverse 1.732, and therefore theta is equal to 60 degrees. This is the first part. Theta p is equal to, therefore I is equal to theta p is equal to 60 degrees. This is the equation 1. So we know the angle of incidence. Now we have to find angle of refraction, and for that purpose we will use the Snell's law. This is the first part. Second part, by Snell's law, mu is equal to sin of I upon sin of R. R is the angle of refraction, जो आपल्याला फाइंड आउट करायचा आहे. Therefore sin of R is equal to sin of I upon mu is equal to sin of 60 degree upon 1.732. Therefore sin 60 is equal to root 3 by 2 upon 1.732. So that is equal to 1.732 upon 1.732 is equal to 1. So take the calculation. Mu is equal to Snell's law, sin of I upon sin of R. We have to find R, so cross multiply. Sin of R is equal to sin of I upon mu. I we have calculated 60 degree. Mu is given 1.732. So sin 60 is equal to root 3 by 2. Root 3 is 1.732 by 2, and this 1.732 will get cancelled, and therefore this is equal to 1 half. So sin of R is equal to 1 half is equal to 0.5. And therefore R is equal to sin inverse 0.500, and therefore R is equal to 30 degree. So angle of refraction R is equal to 30 degree. Angle of refraction R is equal to 30 degree, like this. So in this problem we have used these two equations. Mu is equal to tan of theta p and mu is equal to sin of I upon sin of R. Snell's law आणि ब्रिव्हेस्टर्स लॉ पण इथे यूज केलेले आहे. मागच्या प्रॉब्लेममध्ये आपण हे दोन लॉ यूज केलेले होते. So mu can be coupled by these three relations: Brewster's law, Snell's law, and this critical angle, total internal reflection phenomena. Okay, we will stop here. Polarization we have completed. Next time we will start for new phenomena of light called as a interference. It is a very important phenomena.